Thanks for giving me the coordinates. Hello, I'm Ashok Chaudhary. I'm Senior Application Analyst in Fujitsu, India. And I work closely with our friends parallel lab team for enabling some of our more innovative technical solutions for high performance computing. And the title, as it really shows to you, is our HPC solutions aimed at empowering science and research, plus keeping human-centric innovations in mind for all this transformation, putting across you like keeping your worries off. So, we are empowering the science and research via HPC in India, more specifically in academia and other research segments as well, and the aim is that kind of taking their worries off. So, as I go, so this is in this session I am trying to underline our HPC competence and how we are helping hundreds of researchers and scientists in Indian academia and research to redefine their science environment and streamline the throughput. So, essentially they should get best out of their investment, whether it's the investment of time, money or energy. So, essentially what this is okay. Being a scientist or researchers, please concentrate on your domain, on your science, on your work, and please just leave the high end computing worries to us. We are here to support you in a real, more appropriate ways. Okay. So, there is a background of science and research as it has evolved, and more specifically the computational sciences. So, okay. So, as we really know that there are thousands of years of the experimental sciences which have happened in the human evolution. If I plot the human evolution as a linear baseline for a technological revolution referencing, we would see that the technological revolution has taken over the biological evolution by far. It's something on this linear line of biological evolution. This is really exponential. So, for that matter, say till 2015, what all sciences we had by the end of 2016, and if not by the end of 2016, by the mid 2017, we will be having twice the science and the research and the knowledge done for that. So, this is really exponential in every say 18 months or 20, 21 months. But for thousands of years there were experimental sciences where just experience and the experiments from generations after generations were really coming up with certain notions which in a loose term we can call science. Then of course, a few hundred years of theoretical science, for example Newton's law, Maxwell's equations, and many more sciences happening not only say in Europe, but of course in India, and few decades of computational science. So, all these theoretical sciences which were more specific to putting the science to the mathematical equations, all that has been done by the computational devices. And where we stand today, okay, this is today is a data intensive high end computing science, because as we see, I mean the researchers and scientists, I boast to be called from the same fraternity, that we are really overwhelmed by the huge data which is coming from so many sources and resources, like captured by instrument, generated by simulation, and the sensor networks which different people are using for different sciences. Okay. This is one slide after realizing that there were few decades of theoretical science, and today we are really more interested in a huge data capturing sciences. So, why scientific and technical computation? Simply because this is not really solving the problems, the mysteries, the unfound mysteries, of course, for the human civilization. So, not only solving this problem, it is also creating the new values for us. For example, health and safety. We have the science, of course, the computational science aiding the new drug discovery, then weather forecast, then in industry, innovative manufacturing, and manufacturing which is having a better throughput, more accurate and more human centric. Then science which we use for knowing the mysteries we haven't known in the past. For example, the astronomers and the researchers who are working for the space science and all, they are also aided by this. And this scientific and technical computation, essentially it all needs a supercomputer. Other name for such masters is high performance computing clusters. Okay. And for doing this, here in Fujitsu, we actually look for these three dimensions more seriously than anything else, that we should really work for this human centric transformation with innovation, flexibility and simplicity. Innovation, so like not only keeping the pace with the latest state of art of technologies, but also aiding the rest of the science and the industry with our own creations and the innovations. Flexibility, of course, something which is more democratic and it can be used by more people, not just the experts, the legends, the old researchers, but of course by the newbies, novice, just the students who are actually entering into this area. A simplicity, easy to use, which can be used by more common people than so-called experts. I will touch upon these points as we go through this presentation. Okay, so for this, here in Fujitsu, we have to showcase, oh sorry, I jumped onto the other slide. So we have got experience and tradition, we have got means, and we have got achievements to showcase. Okay. This slide shows that cutting across the globe, of course cutting across the time as well, we have got presence in almost all science, whether this is aerospace and astronomy, it's for academia, it's for meteorology, it's for advanced research, it's for manufacturing, and I'll touch upon all these things more in my coming slides as well. Okay, so this is Fujitsu's competency network. Maybe I can read through this while I come down. Oh, sorry. So Fujitsu Japan for our development, strategic and the service support thing. We have got the Fujitsu technological solution based out of Europe for mainly the primary based Hpc ecosystem. We have got the Fujitsu Systems Europe, having one more company into it, ICT, and Germany. So this is having the expert partners program for us, and the Fujitsu laboratory, which you see somewhere at the right bottom. So this is for our research and development. So essentially at these two centers, we are investing a lot in our research and development. And from this slide you see whether this NVIDIA, Altair, Mellanox, Intel, Red Hat, we have got collaborations as a partnership with most of the serious DDN, data direct networks, DDN, all these players in this space. Okay, so when it comes to tradition, we are not really old, we are not new to this computing. It all started with some of those vector processors in 1980, and by 2020 we have targeted going for our exascale computing. Right now our K computers, they have already crossed a petascale threshold, and our K computer was #1 in top 500 in June and November 2011 list. Now slipped to a position because the newer system have taken the top slot. This is the means. Osberg factory having 77k meter square total space, 35k meter square dedicated for production, and these are some of our daily production statistics, where we produce 10,000 main boards for Fujitsu product and the industry customers, 14,000 thin clients, PC, workstation, mobile PCs, some are 1,200 servers and storage systems per day, as much as integrating 80 racks per day. Okay, this is the area where in this talk I want to specifically emphasize more our parallel application lab. I have chosen to showcase this parallel application lab because for high performance computing, which really aids the parallel computing, more specifically my colleagues and of course me in our France based parallel application lab are really working more streamlined to produce the human centric HPC software stack. Okay. So this is a center of excellence. This is in Toulouse, and people, the experts, they come from parallel programming, and most of them, they are the masters of the most of the latest technologies. The team is a multidisciplinary team of experts. They are people from the scientific computing, mathematics background, computer fluid dynamics, climate and weather forecast guys, life science, physics and the astrophysics. So it's a big team where we do not have just the computer scientists, but we have few experts for the science domain specific. Okay, so these are a few of the ongoing activities. I would be more interested in that right one, that we are integrating and the application onboarding. So that's the one, that onboarding is a one word. So application onboarding for HPC Gateway. So this HPC Gateway is going to be the core tool I want to really discuss in this session. Okay, so these are some of our achievements, the K computer, and this these are the statistics for K computer, and this ITER project in Spain. Okay, Fujitsu HPC Gateway. So with all that prologue, or maybe a long prologue, I really want to rest with this. Okay, so for HPC users, so if I assume that you are having an environment, say one organization based, or maybe say in a collaboration where many departments or organizations, they work closely, you are having say 4 or 5 HPC facilities spread across, say in our Indian geography, and centrally sitting somewhere, somebody want to administer them, want to get the best out of it, and the same time your users, they are say scattered across India remotely and they want to use it. So earlier the things were not that easy, but people used to of course use it really comfortably, but logging into some of those Linux shell and then running those textual commands on the Linux prompt and all. So here we have come with a simple web browser based portal, which really looks like a window desktop. So, this is the feel of it. I will touch upon more. Well, okay. The aim is to, as I told in the beginning even, that the aim is to democratize HPC. So, this is not just for experts, this is for the new users. Not only democratizing this for users specific, this is aimed at bringing the things more handy, more mobile specific. So, even a guy like this can be used to connect to some of your supercomputer. Just you need to open a web browser in such a smartphone, and you can log in into your remote machine, and you can get a fair deal of idea of your HPC jobs running and the work going on. Okay. Actually, the continuation of the last slide, this is beneficial to all, for business managers, for end users of HPC, maybe researchers, at the same time for administrators, the people who are administrating their set of data centers, or even if there is one. So, this web based portal is actually handy for everyone. Okay, this is the platform architecture. What you see here in the dark maroon color, the desktop web application, this is a remote client, which is say on this guy, on some laptop, desktop, and all that, and the rest you see is more specific to the way we have really configured it. And at the bottom are the applications which, as a user of such facility, you want to run. Okay. For user perspective, we have got so many features, and there are many more I haven't captured here, and at the same time we are building a lot more, and they would be out in our coming release. The next one is coming in November only. So, like, it have got intuitive interface. It looks like a web desktop. So, as if you are sitting on your laptop, and the kind of desktop you really see, that look, it have got an inline wiki docs, dashboard options, self-defined layout, easier to understand, like what button it's for what. Applications, we have got encoded application methods for and dynamic and extendable automated workflows, records input. So, while working here, it would record your inputs. So, the input you have given once, they would be recorded, because it happens that whatsoever you are using once, you may be used twice or thrice. It's a known thing. The mobility, as I talk to you, you can even use your phone or desktop. We have implemented it with a flexible GUI with the Rust API. Data collection, so it's record and track usage, identify trends and links, optimize processes that way. It have got remote visualization. So, you can lot more time, the HPC users, they run their simulation, and after that simulation they generate the big amount of data. Then they really get it to their remote home location, say via courier in a compact disk or otherwise, and then on their local machine they would then run the visualization with some of their visualization software and the graphics card etc. But in this case, because this is a web browser based, so you can run it as a remote visualization. Your visualization is running over here, it's on this web browser, you can see it here, and you have got all the options to actually run it with 2x speed or with half x speed. So, you can even control the visualization. So, it's actually the code, those floating point computation and that floating point crunching is happening on your remote machine on your say desktop, what you see just like a movie. Okay, so sorry, I forgot to touch upon this. Like it's good for monitoring by administrators, and it have got the features built in for more than one projects and more than one team to simultaneously use based on the access, the privilege, and the security which we have built into this tool. Okay, essentially this is the look it have got. So this is essentially what is visible to you in a browser. Okay, so one of its tab is open. You can see there is a symbol of gate. We call it Tori, coming from a Japanese word for gate. So Hpc Gateway, and it's so simple. Essentially, what you see, you have got one IP address : one port and the Tori, and this URL. If you just enter this URL, you would be provided with a user credentials and the password prompt, and you put them, and it directly takes you to that specific Hpc facility, of course on its master node. And then you have got such a dashboard looking thing similar to what you see on Windows, and you can do all lot of things which I would touch upon in the coming slides. Okay, you can open a window for your usual old style, the textual work. You can do the remote visualization. That window shows that at runtime you can really fix few parameters. For example, there are few parameter X, Y, G they've been set, and at runtime of your applications there is a graph which being generated. So at runtime you can see if my Hpc simulation is really going in the right direction, or I am getting based on such a plot, I am getting somewhere that it would diverge and it would not really converge. So the integration is not happening properly. I am not going to get the result. So you can break it somewhere in between and restart with the correction and the modification you feel like. It lists all the application, all the jobs running on such system, and it also gives you more monitoring facility, like if you have more than one task, or I mean more than one jobs, one is dependent on the other, so you will really see how they really go. Dependent on one, like one has run, now the other one is running, and after that the third one is running. It's a complete sorry, this pointer is not anyway. This part is complete and that part is still remaining. Okay, it's the one more view for the same thing, for editing, creating the relevant interfaces. So like you have to enter few of the parameters and details for one time, and after that you can create such tests for your application specific. What you see in this window, you have created these somewhere in the past. So all those tests, and this for OpenFOAM, this for DL Poly, this for ANSYS, you have created them in the past, and whenever in the future you just need to remember like which test have got what all parameters tuple you have built into one. You just double click on it and it will submit your job for execution. Based on the availability on that Hpc system, your job would run, and then you have got all those features like at runtime dynamically you really see. You can have a graph of it, and there are a few minor inputs which as a user you need to give, but they are like once and you can use them again and again. It's not that every time you go and manually you do all that kind of thing. As I told you, even if you are not say in your workplace, in your office or otherwise, even if you are outside, you can even view what's happening at your Hpc facility, your Hpc cluster, with on a small device like this, which is turning to be quite handy. Okay, so as I shared with you in the beginning, it have got the different teams or the different projects. There may be N teams, there may be M projects. These N teams, they are working for the M project with the members, editors, administrators, the files they can use, the mount point they can use, the tasks they can fire. So that way, similarly, for teams, what all methods, monitors and processes they have to use with among members, editors and administrators. So you have got this facility, like it helps you to not only democratize, but I say put it in a better shape by running it as a project for specific teams. Yeah, this is the same old one. For each and every data step of your run, what you see, different numbers and a graph which is plotting it. So at runtime, what all parameters you have provided, that I really want the graphs for runtime graphs for all these parameters, they would actually continuously be there for you. Okay, so this have got a file exploration as well. So either you have got a file exploration the way you have in Windows, folders, subfolders and files. So you can use it like a window desktop, or you have got options. So you can open a Linux shell emulator. So in that Linux shell, you can even explore into your file based on the permissions and all that which are available to you. You can use it. You can run the remote visualization. For example, in this sample case with ANSYS. Yeah, these are two more cases for like dynamic monitoring within the web desktop, and one more example where we are using it for precision design engineering with the accelerated imaging. So both of these are case of remote visualizations only. Oh, I felt I was a bit fast. So if you have got some questions, I am happy to answer them. Yes, somebody can help me to have a mic here. Oh,
hello. My name is Natarajan. I would like to know how far it is comparable to that of VMware and HPC, and what are the OS tiers I can connect and operate in the system.
I think these two are different things, and your question do not really fall in the scope of my presentation. And there is a colleague of mine, Pankaj. Can you put on Pankaj mic on? See if it's okay.
Hi, am I audible?
Probably not. Is he audible?
Hello?
Yeah.
Yeah, that's fine. Okay, so to take on your question, as you said, to use a VMware and HPC, so it's really like theoretically if we feel so, yes, in the test labs we can do that. But practically it's not sound so good because there are many layers of encryption between the VMware OS, and then in HPC we are using the InfiniBand and other things. So they are the device drivers itself. So that does not make so much compatibility as of now that we can use it in the commercial environment for that. Hopes that answer your query.
OpenStack in this, how far it deviates?
Pardon? Can you
OpenStack. OpenStack.
In what sense? Like OpenStack for what?
OpenStack layer, if my client want HPC environment with bridging between VMware, OpenStack and multi-testing platform, how I can utilize HPC solutions here?
Yeah, I'm sorry, let me answer it. Actually, all these strategy with the VMware and something, you are actually doing it when you have got one and you want to actually virtually divide it.
Yeah.
In our case, this is something where not virtually, but really you have got thousands of them. Forget thousands, but a minimum of hundreds of them. And actually aim in this field is that you have got one science problem which is encoded into a scientific code, you run it if the problem requires, have got say a problem, end up giving you a solution in 10 days, and if you want that I have parallelized this with my mathematics and with my computation, and if this done on a larger system, a replication of a smaller one connected via interconnect like InfiniBand, so it will end up solving your problem on a larger system, say even in a 1 day or 1 hour. So that's the aim here. So those two things are like here people do not generally do virtualization. It's a real thing. You have got a problem. It can be solved say on a desktop. Great. You have got a larger problem. It cannot at all run on a desktop or say a workstation, or even for that matter even a good server. You can run it on a larger cluster made up of those servers, or like I call each and those servers as nodes. So that's the idea.
Okay. To add to this, I have the point which I want to clarify. Let's say the mainframe application for a banking sector, for a sales data analysis, for a worldwide data analysis, it took some about of a month time to year-end closure report. So whatever the metadata you want to pass it, or else what is the tier you just take it up. Let's say I am comparing with a legacy COBOL-based with a supercomputing environment, comparing with the satellite forecast system with the Cray XMP14, this type of series computing devices with this HPC.
I really appreciate your question. I'm sorry. Can we take this offline?
Sure.
Okay.
Thank you.
Thank you. So nice of you. If there are some more questions, okay, great. Thank you.